Now we come to the TSN architecture and its components. But first we need to define that what is a TSN flow. A TSN flow is a time critical communication between the two end devices, and a TSN flow has strict timing requirements. Now, what are end devices? For a TSN flow, the end devices serve as the source and the destination of this TSN flow. And these end devices run applications that require deterministic communication, for which we need a TSN flow or multiple TSN flows. Now, the end devices are also called as the talkers and the listeners. And then we have the bridges. Here we can see that this TSN flow is passing through these two bridges. A bridge is an Ethernet switch which is TSN enabled, and this Ethernet switch has the capability to transmit and receive the Ethernet frames on a strict timing schedule. Now, apart from the Ethernet, if we are using 5G, then 5G system can also serve as the bridge in a TSN network. And then we have the central network controller, which is also called as the CNC. And CNC has two primary responsibilities. First of all, it determines the routes and the timing schedules for the TSN flows that are passing through the bridges of a TSN network. Secondly, CNC is also responsible for configuring the TSN bridges in order to support these TSN flows. And then we have the centralized user configuration, or CUC. CUC on one end communicates with the end devices, and end devices forward their TSN flow requirements to the CUC, and the CUC communicates these requirements to the CNC so that CNC can reserve resources for these TSN flows.